here? Okay, so since these two triangles are congruent, that tells me that all of their corresponding parts have to be equal by CPCT. Now, there's a lot of corresponding parts. I could get these two parts corresponding, I could get these two angles corresponding, I could get these two sides corresponding. But of all the corresponding parts I could get, the only ones I care about are
Arm. Oh, AM and
AM and KM. I care about the fact that these specific, are these angles equal? Yeah, I don't care. Are these two sides here, AR and KR, equal? Yeah, I don't care. Are AM and KM equal? Yes, and I very much care. Because if I don't state, number 7, that AM equals KM, because, why? CPCTE. Then I have no way of then stating in number 8 that, what was the ultimate goal of the proof?
Arm is isosceles.
That triangle AKM is isosceles. I needed those two sides equal to get the isosceles triangle. So number 8, yes, triangle AKM is in fact isosceles. How do I know it's isosceles?
AM equals AM.
Because two sides are equal. That's the
Definition.
definition of an isosceles triangle. Good. I know it's isosceles because two sides are equal. That is the definition of an isosceles triangle, at least two sides equal. And there we go. Questions on this one? We maybe have time for one more if we hurry. Well, maybe may end up talking through this one rather than actually working it all the way through. I'd like you to draw a rather small acute angle. Draw a rather small acute angle, and draw the two sides of the angle so that they appear to be equal to each other. Call the triangle BAC. Boch. Minus the H. That's in Johann Sebastian. Alright, triangle BAC. What I'd like you to do at the end of CA is to put a perpendicular at the end of CA. So it's going to come up something like that, so that these two lines are perpendicular. Don't draw it real long. Draw a perpendicular and call it DA. And then what I'd like you to do is, at the end of BA, I want you to come down and make a perpendicular to BA. And make this perpendicular, as best you can, about the same length as DA, call it EA. So that BA and EA are perpendicular, and CA and DA are perpendicular. You see what we got going here? Perpendicular, BAE is a right angle, and CAD should be the right angle from the other perpendicular. Then if you would, connect D to B and C to E. We are given that we started with AB and CA equal. We're given that DA, or AD I guess, is perpendicular to CA. We're given that EA is perpendicular to BA. And that these two perpendiculars, AD and AE, are equal. So we got equal lines here, perpendicular to this line, perpendicular to this line, and then the two perpendiculars are equal. We want to prove that if you draw this, no matter how you started with your initial angle, no matter how long you drew your sides or the perpendiculars, if you drew this, that the two triangles that you formed by connecting DB and CE have to be congruent. We're going to prove that triangle BAD, it's a bad triangle, is congruent to triangle CAE. Prove that triangle BAD is congruent to triangle CAE. Let's give it a shot. Let's see if we can go real quick. Two column statements, reasons. First column, or first statement, first reason. Excuse me. Oh, the eraser, he couldn't speak for himself. He just makes noises speaking on his behalf. All right. AB equals AC, DA perpendicular to AC, and EA perpendicular to AB. And these two perpendiculars, DA and EA, are equal. Perpendicular, what does it mean, class? Right angle. So that means that angle DAC must be a right angle. Angle DAC is a right angle. Furthermore, if EA and BA are perpendicular, well, that means that angle EAB must be a right angle. Angle EAB is also a right angle. How do I know these are right angles? Definition of perpendicular lines. I have perpendiculars. They make right angles. Definition of perpendicular lines. That's about all the claim we have. But look at what I'm trying to prove. I'm trying to prove that two triangles are congruent. Notice I've got two sides here and two sides here. So probably side angle side is my method of choice. Furthermore, because it's these two sides, then this angle, which I'm going to call angle 1, needs to be equal to, let's see, here's the sides, this included angle, angle 2. Do we realize if 1 and 2 were equal, I'd have side angle side, I'd have my congruent triangles? The question is how to get 1 and 2 equal. Well, I've got 1, I've got 2. I'm going to go ahead and come right here and call this angle 3. I know this, that DAC is 2 and 3 added together, correct? How do I know that angle DAC is angle 2 plus angle 3?
Because the definition of
No. How do I know that this whole angle is equal to these two parts added together? How do I know that this whole is equal to these two parts added together? The whole is equal to the sum of all its parts. For that matter, let's do the same with angle EAB. What is angle EAB equal to?
everything I read.
What is angle EAB equal to?
3 and then
Angle 3 and angle 1 added together. Because the whole is equal to the sum of all its parts. So we can make that in statement 3 as well. Now, question for you. 1 plus 3 equals EAB, which is a right angle. Therefore, 1 plus 3 adds up to a right angle. Which means, stay with me, that 1 and 3 must be,
equal. Congruent.
if they add up to a right angle, we call them complementary. You have to know definitions, right? So angle 1 and angle 3 are complementary. How do I know? Well, that's the definition of complementary angles. Two angles whose sum is a right angle. So number 4, these angles are complementary based on the definition of complementary angles. Make sure you're writing this down. For that matter, 1 and 3 aren't the only complementary angles I see up here. 2 and 3 are complementary because they add up to DAC, which is a right angle, so they must be complementary as well. Definition of complementary angles. Wait a second. That means that 1 and 2 are each complementary to 3. If two angles are complementary to the same angle, they're equal to each other. Informal statement number 8, 9, something like that, 7. Anyway, we don't care about the number, but we know that complements of equal angles are equal, so that means angle 1 must equal angle 2. Complements of equal angles, or of the same angle, are equal. Complements of equal angles, or of the same angle, are equal. Wait a second. I wanted 1 and 2 equal, didn't I? So that I could have side, angle, side, angle, side. Well, I've got 1 and 2 equal. So I've got sides equal, given. Angles equal, just proved it. Sides equal, given. I have class. SAS, which means my triangles are congruent. So number 6, triangle bad is congruent to triangle CAE by side angle side, and it finishes the proof. Triangle BAD is congruent to triangle CAE by side angle side. And that wraps the proof.
Can we throw these away?
It's up to you. Now, let me throw a little thought out there. On quizzes and tests, I will give you proofs to complete. I will always pull a proof we've already done in class. Now, we do dozens of proofs in class. So, I mean, to try to memorize every proof we've done would be ridiculous. But to, say, skim over proofs that we've done in class wouldn't be a bad strategy. Anyway, your homework this evening is to complete handout 4. Your homework tonight is to complete handout 4. Also, make note we are taking a test on Monday. We have completed the new material we'll be reviewing tomorrow and taking a test on Monday in lesson 30. Lesson 30. Test in lesson 30. All right, once you have that down, you are dismissed. Have a wonderful rest of your day.